Hi, I'm Sarah Powell from the University of Texas at Austin. Today in this STAIR Tailored, we're focused on how we can solve one-step equations when we have an addition operator symbol presented within the equation. And we are going to solve problems like this one, x plus 2 equals 5, using a tool called the Algeblocks. Now we're going to solve these two problems today using the Algeblocks. The Algeblocks are really cool manipulative that can be used to do all kinds of things in algebra, and they're really helpful for helping us help students understand what does it mean to solve equations. And there's two things that we're going to do today. I'm not sure if we'll use them with both problems, but the two concepts we're really going to emphasize are the concepts of zero pairs. So whenever I have a positive and a negative, that creates a zero pair. It equals 0. And we're also going to emphasize that whenever we do something to one side of the equation, we also have to do that to the other side of the equation. We always want to make sure that this equation balances because we have that equal sign right there, and that indicates a balance or relationship between the two sides of the equation. So let's get started on our document camera. So we're solving these two problems here today, x plus 2 equals 5 and 6 equals x plus 4. We're going to use our Algeblocks. Today with our Algeblocks, we're just going to use two of the different kinds of blocks. We have these yellow rods, and today these are going to represent our variable. And in these two equations, they will represent x. But you could use them to represent m or a or whatever variable you want them to represent. We also have all of these units, and these are our constant, and they represent 1. So I've got a lot of them over here. Notice they are pushed to the side of my mat. I don't need them just yet, but they're there in case I need them. And then I'm going to use my sentences mat because I'm solving equations. And what you'll notice with this sentences mat is that there's an equal sign there in the middle. And I even have this kind of smallish balance down here on the bottom. Remember, anytime I do something to one side of the equation, I also want to do that to the other side. So let's set this up. I start with x, and that x is positive, so I'm going to place it here in the positive part of the left side of the equal sign. And we add 2. That's my constant, so I add 2. And it's also positive, so I place it here in the positive part. And then that equals 5, so I'm going to place 5 cubes over there. So if I look at this as a teacher, I can walk around and see each student has x plus 2 equals 5 set up with their manipulatives. Now we want to isolate this variable, which means I need to remove this constant right here. So if I want to move this constant, there's two ways that I can do this. Notice I have positive 2 on this side of the equal sign and positive 2 on that side of the equal sign. If I have positive 2 on both sides, I can take that away. I can remove it from our sentences mat. And so that's one of the ways I could solve this problem. But that may not always be the case. I might not always have 2 positives on each side, so we can use zero pairs to remove this constant so that the variable is isolated by itself. So I bring in negative 2. Those create 2 zero pairs there that would make this side equal 0. But remember, if I brought in negative 2 to this side, guess what I have to do to that side? I also have to bring in negative 2. Now I want to push pause right here, and I want to get out a piece of paper, and I want to solve this equation as we would often do this with students. So I'm going to rewrite my equation right here. X plus 2 equals 5. Now often, a lot of teachers may draw a line down from the equal sign, so to show that I need to balance these two sides. And to isolate this variable here, I'm going to subtract 2 from both sides. Okay, that probably looks familiar to a lot of you who teach algebra. Now look at this math here. So this is math in the abstract form. Here is math in the concrete form. I have x plus 2, minus 2, 5, and minus 2. So the important thing with manipulatives is that your manipulatives match the abstract math that you are trying to get students to understand. So then what happens? I create these zero pairs, that equals 0 and that equals 0. I can remove them. So 2 minus 2 is 0, and often we kind of just cross that out, but if you want to write 0 there, you can do that. And then I see that I have 2 zero pairs on this side, so I move those zero pairs off of my mat. 5 minus 2 is 3. So x equals 3. And look what I have. X equals 3. Pretty cool, right? Let's try this next problem. I'm going to go ahead and remove that work and move all of my manipulatives to the side. All right, this problem has 6. It's a positive 6 because there's no negative symbol in front of the 6. And that equals x. Remember, my yellow rod represents x. X plus 4. All right, so I want to isolate this variable. That means I want to subtract 4 from both sides. Again, if I have positive 4 on this side and positive 4 on that side, I could go ahead and subtract that from both sides and see that x equals 2. But that may not always be the case, and we always want to set up students for like, well, what happens if this was negative 6? So here, I'm going to use 4 0 pairs. I'm going to create 4 0 pairs here. But if I added negative 4 to that side of the equal sign, I need to bring in negative 4 to this side of the equal sign. And then I can see, well, positive 4 and negative 4, those equal 0. And I have positive 4 and negative 4, those equal 0. So in the same way that I did before, I can see that 2 equals x, or if we want to read this, x equals 2. That works just as well there. So those were just 2 examples of how we can use those Algeblocks to help students understand important algebraic concepts, such as the use of 0 pairs, and whatever you do to one side of the equal sign, you also have to do to the other side. We'll see you in other STAIR tailored sessions.